Here, we're going to factor a quadratic with the lead coefficient not equal to 1. Here's our quadratic trinomial, and the lead coefficient, a, is 6, so it's not equal to 1. So let's write this down. A is 6, b is 7, and c is 2. In this case, again, we're looking for two values, m and n, such that m plus n is equal to b. So we need to find the two values, m and n, add them together, and they're equal to b, which is 7. M times n will equal a times c. So when we find m and n, when we multiply them, they're equal to a times c, 6 times 2, and that's 12. Let's factor 12. 12 factors into 1 times 12. If we add 1 and 12 together, we don't get 7. We want the sum to be 7. 12 is also 2 times 6. And if we add 2 and 6 together, we still don't get 7. 12 is equal to 3 times 4. And if we add 3 and 4 together, we get 7. So m and n are 3 and 4. 3 plus 4 is 7. 3 times 4 is 12. Now, what we want to do is we want to go up to the original problem and rewrite the first term, which is 6x squared. But for our 7x, we want to split it into mx plus nx. In other words, 7 will be equal to 3x plus 4x, because 3x plus 4x, 3 plus 4 is 7, 7x. And then we add the 2 to the end. So the first thing we do is we split the middle term. The next thing we want to do is we want to group the first two terms together. So 6x plus 3x, we group these together. What we're doing after we split the middle term is we're doing the factor by grouping. And we group the next two terms together. And we factor the first two terms, then we add that to factoring the second two terms. When we factor the first two terms, we'll find that 3x factors out, and we have the monomial 3x times 2x plus 1. Don't forget to bring down this plus sign right here. Now when we factor the 4x plus 2, we're going to pull out a 2, and it's 2 times 2x plus 1. Notice that what we have here is the term 3x times 2x plus 1 added to the term 2 times 2x plus 1. So we want to factor out the greatest common fact between these two terms, and that is the binomial 2x plus 1. When we factor the 2x plus 1 out, what's left? Well, in this term, if we remove the 2x plus 1, what's left is just the 3x. Don't forget the plus sign. And here, when we factor out the 2x plus 1, What's left is 2. So here's our answer. The product of two binomials. Here's another example of a quadratic trinomial that we want to factor. Let's make this subtraction add the opposite. So in this case, A is 2, B is -1, and C is -1. As we did in the previous example, we want to find m and n and then split the middle term into mx plus nx. We'll end up with 4 terms, and we factor by grouping. Okay, we need to find m and n such that the sum of m plus n is b. So we're going to take whatever we find for m and n, add them together, and they'll equal b, which is a -1. And then we want to multiply m times n, and that will be a times c. So when we find m and n, their product is a times c, which is 2 times a -1. So it's a -2. So we're trying to find two numbers. So that if we multiply them, get rid of that. If we multiply these numbers, one will be positive and the other will be negative. So say positive and negative, because a positive times a negative is a negative, which means that they're also positive and negative when we add them. So what we're doing then is when we add them, we're going to find the difference. So the difference will be negative between the two numbers. The larger one will be negative because the result is negative. So we need to factor 2. Let's factor 2. So 2 factors into 1 times 2. Well, that's it. That's all it factors into. So for this to work, m and n have to be 1 and 2. 1 times 2 is 2. Since we're adding them together, the difference between 1 and 2 is 1, but the result is negative, so the larger digit, 2, is the larger digit. It must be positive. Positive 2 plus -1 is a -1. Positive 2 times a -1 is a -2. So this is our split. So we're going to go back up to the original problem and write the first term, which is 2x squared. And then, instead of writing the second term, which is a -x, we are going to write mx, which is 2x, plus nx, which is a -x. And then, if we look at these, if we add these two together, 2x plus a -x, we get a -x. So we can actually add those two together and get the middle term. I'm going to pull the blue out if I can. Let's just pull that blue out. I don't want it to be too busy, so I'm pulling out my blue line with an eraser. Okay, and so let's add the last term, which is a -1. So this is the split the middle term. And as soon as we've split the middle term, we have 4 terms, and we're ready to do factor by grouping, which means we group the first 2 together and the second 2 together. Factoring out from the first 2, we can factor out a 2x, and what's left when we factor out a 2x? An x plus 1. Because 2x times x is 2x squared, and 2x times 1 is 2x. Don't forget the plus sign. Now we want to factor out here a -x plus a -1. If we factor out a -1, we get an x plus 1. Because a -1 times x is a -x, and a -1 times 1 is a -1. Now we have the sum of two terms. Here's our first term, 2x times x plus 1, plus our second term, a -1 times x plus 1. We want to factor out our matching binomials, x plus 1. When we factor out x plus 1, we get what's left, 2x plus a negative 1. There's our answer. Factoring this quadratic trinomial gives us the product of two binomials. I want to point out something here. When we split our middle term into mx times nx, the order for 2x and a negative x doesn't matter. We could have swapped them. If we swap them, when we work out our answer, it will be the same. So I wanted to point that out to you.